Welcome, pre-calculars, to section 5.6, talking about compound interest. So these are the four formulas that you are going to learn to love right now for pre-calc, and then actually for the rest of your life. You're going to need them. It's going to be so awesome with loans and interest and all this fun stuff of being an adult. So learning it now is just a little preview of your future. So here are the main four formulas: compounding annually, regular compounding, continuous compounding, or doubling time. So I have all the variables listed for you in our red table, but we have to be careful here with regular compounding. This is regular in terms of it could be annually, where the n variable will be 1, which actually looks just like the annual compounding because dividing by n or dividing by 1 goes away. It could be quarterly. When it's quarterly, think of a quarter. There's 4 quarters in a dollar, so n would equal 4. Semi-annually is when n is 2. Monthly, there are 12 months in a year, so you would have n being 12. And daily, there's 365 days. So that would be the n variable that you replace here and in your exponent. Let's go ahead and jump into some examples using these formulas. So computing percentage increase. An amount of $100 is increased by 15%, and then the new amount is increased by 15 more %. Is this the same as an overall increase of 30? Let's figure it out. So here's the solution. To increase $100 by 15%, you multiply by 1.15. So that's right here. This is the first increase of 15%. So 100 times 1.15 is actually 115. You increase it by $15 actually. Then you now want to increase that amount by another 15%. So you're going to multiply that by 1.15. And notice you will get $132.25, which is exactly what it said you would do in the math above. So you raised it once by 15%, then again that new amount by 15%. However, if you increase it by 30% from the get-go, you would do this multiplication, increase by 30%, and you would get $130. So actually, a big takeaway here, it is a better deal to increase by 15% twice versus a one-time increase of 30%. So sometimes you really have to break it down, do the math. If someone asked you, do you want to increase by 30 or increase 2 times by 15, take the better deal. This is definitely bigger than 130. Every piece of money counts, my dears. So it's important to know how to increase. We're also going to look at this table, which is about interest. So yes, you will be paying interest on loans, on your house, on your car, something like that. So it's important to understand interest. If you notice, after 1 year, you start with $1,000. You have a 10% interest. Right here, that's 10%, right? Increase by 10%. So then it's $1,100. Then that next amount gets put in for year 2. You again increase by 10%, and you get a new amount. That amount is used for year 3, year 4, year 5, all of that going through. Now the question is, how much interest is paid each year? So let's break it down. The first year, you have to pay $1,100, and the initial amount was $1,000. So your interest for the first year is $100. Okay, pretty standard. For the second year, you're now paying $1,210 minus what was put in is $1,100 from the previous year, you know, that arrow. So interest for your second year is actually $110. Ooh, paying more interest. Third year, you're paying $1,331. What comes in from the previous year is $1,210. So on the third year, you're paying $121 of interest. So yes, a big takeaway. Interest increases every year. Yuck. I'll even put a sad face, right? Like, not fun. So that's why you want to pay off your loans as fast as possible. You want to make sure you are smart with your money, because otherwise you'll be paying more and more interest depending on how much money you have. But it's okay, guys. We'll all get through it. We're all going to be adults. It's going to be awesome. Example 2. Suppose that $2,000 is invested at 7.5 interest compounded annually. Okay, so that's this formula. You're welcome. I already put it there for us. How many years will it take for the money to double? That's awesome, right? We want our money to double. So let's fill in what we know. So we know that $2,000 is invested, so that's my principal, my P value. I know my rate is 7.5%, but whenever you put a rate, it needs to be in a decimal. So move that decimal place over 2. This is the R value. Okay, do not put 7.5. Don't put the percent. It has to be the decimal. Maybe write a huge star or something. Otherwise, your numbers are going to be very, very off. So you're going to add 0.75. My T value is time that I'm solving for. And I want to know how many years will it take for my money to double. So you now want your value to double. So you want your amount in the account from 2,000 to become, oops, sorry about that, to become 4,000. Let's just plug in through your values. Now, we should be familiar with solving this. I'm going to first divide both sides by 2,000. I'll get 2 equals 1 plus 0.75t. And this should be familiar. You're stuck in exponential, right? The t is up on the exponent. So in order to get it popped in the front, take the log of both sides or the ln of both sides. Remember, both will work. Doing so makes that makes the t pop in the front. And now you have this value, which, if you're okay, I'm just going to combine it. I want to get t by itself, so I'm going to divide by ln of 1.75. You're going to type it in your calculator very carefully. You're going to remember your parentheses. Oops. Sorry about this, guys. It should be 0.075. I was like, that got pretty big pretty fast. So it's supposed to be 0.075. So put a 0 here. I'm so sorry. If some of you already caught that, you're like, wow, I'm slipping. I know, I'm sorry. Put your parentheses When you put in your calculator, please verify you can get 9.6, and this would be your years. So please make sure you can type it in your calculator, but this is plugging into the compound annually formula and solving for years. Couple more, we're going to compare annually to quarterly. Sometimes it's important to know, should I compound this annually or quarterly? In the end, you want to make the most money, right? So let's see which one's best. So suppose you have $1,000 placed in a saving account, 10% per year. How much is in the account at the end of 1 year if the interest is, part A, compounded each year? Look, isn't that nice? It already tells me N is 1, right? Year is 1. So let's plug in what we know. I don't know my amount in the account. You know your principal is $1,000. My rate is 10%. I am not putting 10% in though, right? You want to move the decimal over 2. You will be putting in 0.1 is your R value. Don't forget that. So it's going to be 0.1 over 1 raised to the N is 1, and we are solving for T. So I simply plugged into my compound annually formula. Know that you by all means could have plugged into A equals P times 1 plus R to the T. That's the same exact equation. Either way works for me. So doing some simplifying, you'll see, oh, it actually already tells you the 1 year, guys. I'm sorry. You already know the time. It wants 1 year. Instead of T, put a 1. So we're just simplifying. So just typing into our calculator. Make sure you first do 1 plus 0.1 times by 1,000. But you are going to get 1,100. So that is if you compounded each year. Let's compare that to if you compound quarterly. So same formula, same initial amount, same rate, but now it's quarterly. So N is 4 for quarterly. N is 4. Type it in your calculator. Compare with me. Should get $1,103.81. So in the end, which one's better? This one, right? You want to compound quarterly is better. Because you make just a little bit more money and every penny counts. We have example 4 and 5 left. I'm going to start 4 with you and then have you hopefully try number 5. So example 4, compare the account totals for $12,000 deposited into quarterly and continuously compounded accounts after 5 years with an annual interest rate of 9%. So again, we're going to compare. The first one's going to be quarterly. And then we're also going to compare it to continuously. Sorry. Continuously. Let's go to our formulas. Quarterly is going to be A equals P times 1 plus R. I'm already going to put over 4 because I know quarterly you have to put 4. So that's my formula. Let's plug in what I know. I know that the principal is $12,000. I know my rate is 9%, but I'm not going to write the percent. I'm going to write the decimal. And I know the year is 5. Typing that into your calculator, well, $18,726.11. That's how much you would have if you compounded quarterly. Let's compare that to continuously. Continuously has the formula P-E raised to the RT. I know that just from the beginning of this note sheet. Plug in what I know. 12,000. E, the rate is 0.09 times 5 years. Typing that into your calculator, you should get 18,819.75. So now the time comes to compare which one's better. Well, it's going to be continuous. Right? This one's better. This one's more money. You can write yourself a sentence that continuously is better because you're going to make about $93 more than if you compounded quarterly. Example 5. You need $15 for a down payment on a new home for 5 years. If the bank guarantees 4% on a certificate of deposit, a CD, that compounds monthly, how much needs to be deposited in the account today? What if it is compound continuously? Okay, so we have two things we're going to compare. The first one is monthly. And the second one is continuously. So looking at our formulas, I'm going to get you set up. Monthly is this formula. The N value is going to be 12 because there's 12 months in a year. Continuously, that formula is right from above. P-E-R-T. Now, it's asking how much money needs to be deposited today, which means you're going to be solving for the p-value. We don't know that. Okay, that's the unknown. You need $15,000 for a down payment, so that becomes the A value, my dears. Oops, I'll change my colors. Okay. You know the years is 5. You know the interest rate is 4%, so don't forget, even though it's 4%, you're going to write 0.04. After you solve, you should find out the results that they're actually going to be the same amount. So please make sure you do this math, plug in your values, and solve. I'm going to ask at the beginning of class what this amount is, and then you will be good to go. Good luck, peeps.